Good evening, kids. I am your Sridhar sir, physics teacher. Today we are going to discuss the 3rd April Shift-1, the morning shift, JEE Main 2025, the physics paper with the solutions. So the paper is moderate. I think there's a third paper what we have come across, and it's a moderate paper. Number of easy questions are 10, the tough questions 4 compared to the other two shifts. There's a third one. Little bit some tricky are there, around 4 are there. Moderate questions will be 11. Hmm? And overall the paper is moderate and easily all just revise the concepts, formulas. They were able to manage 20 to 21 questions very comfortably. So the coming shift also all preparing the afternoon shift. Then next again on the 4th, 7th, 8th. The methodology is same. Read all the theory. What is our targeted? How much of syllabus you have put target? 50%, 60%, 70%, 80%. Those who are targeted 90%. You read all. Then afterwards, revise all the formulas. Recollect. Ask yourself, do you know this formula? Do you know this formula? Do you know, can you remember this formula? I think focus more on that one. So like that you keep on read things and check yourself, are you comfortable with this content, this content? Hmm? So set right everything, get ready for exam. Really, the papers, the way the physics being asked, manageable. Till now, it's manageable. Maybe if it all tough comes, maybe 2, 3, 4, 5 questions will be tough. But still, I think the 20 questions will be there in your hand. And check all the topics like the missing topics is what definitely you have to give priority. What all topics till now? I think by this time evening, 4 shifts, 4 papers came. Those who are writing on the April 4, definitely whatever you check the concepts which till now didn't ask, they'll become important. Those are writing on 7th, 8th. All the topics which are asked, still what is left over, I think they are the probability. Like that, you can make a guess. So, suppose you made a guess of around some 50 subtopics, in that maybe 10 or 8 will help you. So many strategies are there. It all depends on your patience. The paper is moderate, not an easy, it's a moderate paper. Okay, we'll start with the paper discussion. Okay, there's a question now. The first question, it belongs to the chapter oscillations or SHM. The subtopic name is SHM of spring block up in a block system with friction. There are two blocks are there. You can see here. There is a one block. Next we have the other one is another block. There are two blocks are there, and there's a spring connected, and the surface between the blocks is rough. Let me read the question. The figure below shows an oscillating system of two blocks and spring. The horizontal surface is smooth. This is smooth. This surface is smooth. And the contact between the blocks is rough. This is rough with quotient of static friction mu. Consider the blocks of mass m is always stationary relative to m, means no slipping. Always stationary means no slipping. Choose the correct option regarding the statement below. Maximum frictional force between the blocks is mu mg. What is the maximum frictional force? Maximum frictional force between the blocks is mu mg is telling. Then the time period of oscillation, definitely the time period of, there's a correct statement, because what is the total mass of oscillation? Small m plus capital M. Friction between the blocks at any instant of time. Friction between the blocks. So we'll do one thing. When these are oscillating, here spring force will act. And with this. So the friction force here it will be like this. Then what is x? X equal to a cos omega t. And the friction force and the acceleration of this will calculate a equal to minus omega square x. Then this will become minus omega square a cos omega t. The maximum possible acceleration is omega. What is omega? Omega we know time period. From here we'll get the omega. Omega will be k by capital M plus small m into a. 1 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / 2 / There's a maximum acceleration. Okay, fine. So there's a maximum acceleration. Then who will accelerate this upper block, the friction? M into A max. This will be the maximum friction force. M into K M plus small m into A is the amplitude. We are going to determine the amplitude. So tell me, like, what is the maximum frictional force between the blocks? Depends on these quantity here. It all depends on this one. So this will be ruled out. Frictional force between the blocks at any instant of time. The frictional force, in fact, will vary here because the acceleration is a function of x. Frictional force is a function of x. The frictional force itself will vary. And it will be varying like this, the graph. Very good concept, it is. Okay, the graph like this. Okay, no, it varies. At any instant is no, this is not like it will vary like at any instant of time. This equation, so this is also ruled out. So only A is correct. A, B, C, all three are correct. B and C are correct. No, only B is correct. Very little bit tough question. You could, you should avoid. If you have a time, okay, you have to work out. You should think all these ideas. Then you can pick up the suitable option. We'll take the next question. There's a question belongs to the chapter capacitors. The idea in what is capacitor partially filled with the dielectric slabs. Is a composite dielectric slab is filled up. So here they are in series. The effective capacitance 1 by C1 equal to epsilon naught E1 A by D by 2. Epsilon naught E2, the dielectric constant, this is the dielectric constant, A by D by 2, or this will become 1 by C1 D by 2 epsilon naught A D by 2 epsilon naught then these two are in parallel. Effective capacitance will be epsilon naught E1 A by 2 D this is a capacitance. This will be D by epsilon naught C1 by C2 is asking the ratio of C1 by C2. We'll take like this, C2 by C1. Later on we'll take the reciprocal, no problem. Or C1 will be, solving here I'll solve it. C1 will be 2 epsilon naught A D then we'll C1 by C2. This one only. Next denominator epsilon naught A2D D will cancel out, so 4 whole square. This in detail will be given. So these are the this will be ratio of C1 by C2. This will be your option. So I think you should remember this formula. It's a partial filter. They are here in series. These two capacitors. This will become one capacitor. This one capacitor series. We use this formula. They are in parallel here. Okay. Huh? We'll take the next question. This question belongs to the chapter kinematics. The idea involved is projectile motion with the graphical analysis. Let me read the question. From a horizontal surface, a particle is projected with a speed u. Which of the following correctly represent the variation of maximum height above the surface attained by particle as the angle of projection is varied? Here what we have the situation like this. There is a part, this is a surface. Here I am going to project with a speed u at an angle theta. Then is going to describe the projectile motion. This is a maximum height. So this maximum height ascended depends upon u square sine square theta by 2g. Put theta 90. When theta is 90 degree, it is the maximum height ascended. Just its height. Maximum height is u square by 2g for theta equal to 90 degree. As you keep on increase theta, h will increase. Okay, this is ruled out. At theta equal 90 degree, it will be maximum. So this is something like a maximum. Okay, this is a rule out. Okay, fine. Here we have the condition. Now, according to these two graphs, so what it's telling is like somewhere at one particular angle, the maximum height will be 0. This is not possible, no? The maximum height should keep on increasing here. So only this is the better option. You need not to do one thing. First odd one out. Then something here at a specific angle, it will become 0. The height ascended. The height ascended can never be 0. Only when theta 0, h will be 0. H will be 0 only for theta 0. Theta 0 only, it should be like a maximum height ascended should be 0. So this becoming 0 at certain non-zero value of theta not possible. So therefore I am not picking up this graph. You need not to bother about this shape of the graph. Roughly you have to estimate. We'll take the next question. And this question belongs to the chapter work energy power. And the idea involved is conservation of mechanical energy. The question is, an object is dropped from a height s. At a point, its kinetic energy is 3 times its potential energy. Find its height from the ground and speed at that point. So here basically we are going to drop a particle where the particle is dropped from here. Drop it from rest. What is the height? Height will be s. Then when its kinetic energy is 3 times its potential energy, somewhere here it will happen. What is the kinetic energy at this point? The kinetic energy at this point, it will have the kinetic energy, it will have speed, and it will be at height h. Find the height from the ground and speed at that point. What is the kinetic energy here? Will be 3 times that of potential energy. What was the initial potential energy? mgs. The total energy should be conserved, no? Yes. U naught, it is released from rest, plus k naught. I'll solve it here. Should be equal to k plus u, kinetic energy plus potential energy. U naught will be mgs, kinetic energy is 0. There's a kinetic energy. Find its height find the h and speed we have to calculate. So what is the potential energy? Potential energy will be k by 3. So this will become mgs equal to 4k by 3. mgs equal to 4 by 3. What is the kinetic energy? mv square by 2. So this will become v is equal to 3gs by 2. That's the speed. After this we have to calculate the h, and we know what is the potential energy. Potential energy will be k by 3, and potential energy is what? mgh. This is h equal to 0. Kinetic energy, already we know kinetic energy. Kinetic energy will be 3 mg. K by 3 will be mgs by 4. Take help of this one, this equation. So why u equal to k by 3? Because it is given condition, no? There is a given. So therefore k by 3 will be mgs by 4. So what is h is equal to now? H equal to s by 4. Good question. You should really analyze. This is the conservation of mechanical energy concept. Oh, yeah. Let me go for next question. Okay, kids, we have the question. This question belongs to the chapter electrostatics. The idea involved is potential of a conducting shell. Inside, on the surface, outside. The basic formulas, if you know, you can manage this question very easily. Let me read the question. The electric potential at the surface of shell of radius 10 centimeter is 120 volt. So what is the potential on the surface? Here 0.3. This should be equal to kq by r, kq. There's a value of kp, and how much this is equal to 120 volt. This is given for us. Then potential inside everywhere will be same as that on the surface. We know V1 equal to V3. Potential at a distance R equal to 15 centimeter. Then potential outside will be KQ by R. KQ by R. So let this R, here capital R, here capital R will multiply. KQ by capital R, R by small r. KQ by capital R, 120. Capital R is how much? Radius. Radius is how much? 10. This is 15. So that we can calculate the potential outside will be 120 into 2 by 3. 80 volt. So potential here 80 volt on the surface, 120 volt, everywhere inside 120 volt. This will be your option. A simple idea: potential on the surface, potential on the surface, potential inside will be that on the surface. Potential outside depends on the radial distance. I think the basic definitions of potential of conducting shell, if you know it, you can manage this question. Okay, fine. Okay, this question belongs to the chapter fluid dynamics, and the idea involved is Bernoulli's theorem and velocity of reflex. These are the basic concepts. Okay, container of height 1.6 meter. What is the height of this? 1.6 meter. Is having a small hole at height of 0.9 meter. The small hole from the ground. Find the speed of Flex from the hole. Is asking to get this velocity. The velocity of Flex out of 1.6 meter, how much will be left over? H will be 0.7 meter. Then what is the velocity of Flex? Velocity of Flex formula will be root of 2gh. What is the depth of the hole? 2 into 10 into depth of the hole will be 0.7. This will be root 14 meter per second. So approximately nearest value will be 3. G 9.8 is telling 9.8. Okay, let me multiply. Okay, we'll take the value of G. It is given 9.8. 13.7 will come. Under root of this will be 3.7 meter per second. Okay, these are the options available. Just now I checked it. So we can pick up this as option D. This is the velocity of Flex. It just depends on the depth, this particular depth of this hole. This is a small hole. At what depth it is from the free surface. Okay, fine. Huh? So on what basis I'm writing this equation? Because the hole is here. The velocity of Flex depends upon the depth of hole from the free surface. This is the free surface. So 1.6, 0.9 will be 0.7 meter that we have substituted. Okay, then. And the chapter is moving charges and magnetism, and the idea involved is F equal to BIL. A current carrying wire kept in a magnet field, then how much of force acting on it. This is a current carrying wire, the length of this is L, current carrying I. We have to calculate the force. The force, resultant force will be acting on in this direction, which is equal to BIL. Magnetic field 0.15, current flowing is 8, length is 4 meter. Force in millinewton is asking. 8 4 are 32. So this will be 0.15 into 32. 4.8 it will come. Convert that into millinewton, we'll get this answer. A simple idea based. Huh? Just if you know F equal to BIL, there is enough. No, he didn't give any diagram, just only that is telling the magnet field is perpendicular to the current carrying wire is placed perpendicular to magnet field. So this basic diagram, you should have the imagination. And this is a wire itself. Okay, kids, done? We'll move now. We'll move to the next question. Okay, this question belongs to the chapter radiation. And the idea involved is radiation pressure. A point source of power 450 watt is emitting light in all directions. So I have this is which will emit light in all directions. It will emit in all directions, not only this. At a distance of 2 meter is asking what is the radiation pressure. 2 meter, okay, we'll choose somewhere here. This is 2 meter. At this particular point, there's a power of source. We have to calculate the radiation pressure. So first we'll calculate the intensity. How you calculate intensity? Power by x square. What is x? X is a distance. Power will be 450, 4 pi x square, 2 square. 450 by 16 pi. This is the intensity of light at this particular point. What are these lines? Light propagating. Then what is the radiation pressure? Given by I by C. 1 by 3 into 10 to the power of 8, 450, 16 pi. This will be approximately 2. So 450 by 16 pi. 16 pi is what? Pi will be 3, will be around 48. Here we'll get the 10. This will be 0.33, 10 to the power of 8. This is approximately 10. So the final calculations will be 3.33 into 10 to the power of 8. Approximate 3 into 10 to the power of 8 Pascal. It's all about calculations. Here is what the tricky calculations are there. Hmm? Okay, fine. We'll move to the next question. The chapter name is rotational motion, and the idea involved is accelerated rolling motion. Then we have this sphere, a force 49 Newton force is acting, and assuming no slipping here, so definitely the friction in what direction will act? The friction will act as a sphere. The friction will act in this direction. Center of mass will accelerate. It will set up a torque. Pure rolling is this. Now we'll write down the equation. F plus small f equal to ma. It will set up a torque about 0.2 applied force F into R, torque by friction force equal to I naught alpha. For pure rolling, A equal to R alpha. Further we'll solve it. F minus small f into R 2 by 5 mr square. Alpha will be A by R. F minus small f will be 2 by 5 ma. Acceleration of the sphere we have to calculate. So there's a one equation, this other equation. This will substitute here, or we'll add up these two equations. So 2f is equal to 7 ma by 5. What is acceleration equal to? 10f by 7m. F will be 49, 7 into 20. 7 by 2 meter per second square, which is nothing but 3.5. Very, very, very important decisions you have to take it here. There will be rolling friction will be acting. Sir, why you are assuming forward? Because definitely you apply the force at the threshold point. No? For solid sphere, what is the threshold point? 2r by 5. It is acting above that. So therefore the friction will act forward. No, sir, I'll assume backward. As you assume, still you'll get the same answer. Whether you assume friction forward or backward, you'll get the same answer. There are only two possible directions of friction, either forward or backward. Here, you can assume any direction, you'll get this answer. You assume any direction. If you solve it, if you get negative, change direction. If you get positive, what you assumed is right. We'll move to the next question. Okay, this question belongs to the chapter ray optics, and the idea involved is lens maker formula. A biconvex lens. There's a convex lens having radius of curvature. This is 10 centimeter. This is 15 centimeter. The focal length of the lens, we know how much? 12 centimeter. Is asking to calculate the mu of the material. Or the formula, lens maker formula, 1 by f equal to surrounding medium is air. If you didn't mention anything, you should consider air. Mu minus 1 by r1 minus 1 by r2. Why? Because there's a incident ray is moving towards right. R1, the radius R1, center of curvature will be here. So the R1 you will measure in the direction of incident ray, whereas the R2 will measure opposite to incident ray. So therefore this will be negative. Focal length, this is 12. Mu we don't know. R1 will be plus 10. I'll do one thing. I'll substitute now with sign. R2 will be minus 15. Solve this, we'll get mu 1.5 or 3 by 2. Directly the lens maker formula. The chapter name is moving charges and magnetism. The idea involved is Biot-Savart law. The problem is based on Biot-Savart law. A current carrying wire is bent as shown in figure. Magnetic field at center of the semicircles. Take R1 equal 4 pi, R2 equal 6 pi. We have to calculate the magnetic field. Here the current I is flowing. Then there are four segments are there: semicircle, straight segment, and semicircle. No magnetic field due to straight segment because the pointer will lie on the axis. There won't be any magnetic field due to this straight segment. What all magnetic field will be there? Only due to this semicircular one. So the net magnetic field at point O due to this wire will be into the plane. Mu naught I to R2. Angle subtended. pi, or say magnetic field due to the semicircle will be 4r2. This will be into the plane. The current will flow, will be out of the plane. Substitute all these values. R1 equal to 4 pi and R1 equal to 4 pi and R2 equal to 6 pi. Solving this, we'll get this answer, nearest value. What is the value of mu naught? Mu naught value will be 4 pi into 10 to the power of minus 7. So substituting, we'll get answer in terms of current here. The one into the plane, you take negative. The one which is out of the plane, take it positive. The problem based on the dual nature of matter and radiation, and the idea involved is the photoelectric effect. The work function of metal is 3 electron. The color of the visible light that is required to cause the emission of photoelectrons. Definitely the wavelength of the light should be equal to 3 electron volt. Then lambda should be equal to Sc by the energy. Sc will be 1240 Armstrongs. The energy will be in the electron volt, 3 electron volt. So this will become 12400 by 3. This will become 4133 Armstrongs. Then if you compare the spectrum, Vibgyor spectrum, this will be 4000 approximator, and this will be 7000. And what about the yellow will be this one, and the green will be around 5500 Armstrongs. So definitely yellow is ruled out, red is ruled out, green is ruled out. So therefore it has to be the blue. I think the spectrum, you should remember the EM waves concept. Rough idea, what is the wavelength of the blue color light, indigo, blue, green. We know for red and yellow will be the average of these two. Definitely this will become green. Definitely the green should be the lower value compared to yellow. Then the blue should be lower value. So therefore it has to be beside the green, it should be blue only. Okay, this question is based on the current density, and the idea involved is the resistance of a wire. Some series parallel concept is there. Parallel, resistors in series. Sorry, resistors in parallel. So I have the okay, there is a wire. Then here it will have the half of the resistance, R by 2, and they are parallel. So the effective resistance RAV will be R by 4. What is R? R is the total resistance. R will be rho perimeter length L area of cross section. So 1 by 4 it will be. So RAB will be. So rho will be 2 into 10 to the power of minus 6. Length is 25 meters. Area of cross section 5 millimeters square. 10 ohm. Then R by 4. 2.5 ohm. So somehow this diagram you should imagine resistance across the diameter. We'll move to the next question. Okay, this question belongs to the topic current density. And here the emitter concept. The idea involved is emitter. We have here the emitter circuit. It is having the resistance how much? 240 ohm. Is asking to get the reading of the current through the emitter, or reading of the emitter. Let the current flowing here be I. Here let it be capital I. Here how much it is? I minus I. Will give the polarity. These two are parallel, the drop should be equal. So based on that, 240 into I, applying the Ohm's law. The resistance of the emitter is 240, the current is I. This should be equal to 10 into I minus I. So 240, 250 I equal to 10 I. The equation will be 25 I equal to capital I. We'll write one loop equation, plus 20, here, plus 20 minus 150.4 capital I minus 240I equals 0. We have to replace capital I. $25I. So 25 into, we have to do the calculation, no? 25 into 150.4, 3760. So this will be 20, will be 4000 I, or I is equal to 1 by 200. 5 milliampere. Good calculations. Calculation based. You should be very good in calculations. You know all this KCL, KVL, parallel series. It's all about this calculation. Okay, sir. We should be perfect in calculation. Yes, definitely. We'll move to the next question. Okay, the chapter name is thermodynamics, and the subtopic is adiabatic process. A ideal gas with adiabatic exponent 1 gamma initially at 27 degrees compressed adiabatically from 80 cc to 20 C. The final temperature of the gas T1 V1 gamma minus 1, T2 V2 gamma minus 2. Initial temperature 27 degrees. 27 degrees in converting to Kelvin will be 300 Kelvin. Volume of this gas is how much? 80, 800 gamma minus 1, T2. The new volume will be 200 gamma minus 1. The units you not to bother will cancel out here. T2 is equal to 300. This will be 8 by 2, 4. Gamma value will be 1.5, 1.5 minus 1, 300, 1 by 2, 4 to the power of 1 by 2. So this will be final 300. 4 we can write 2 square, 600 Kelvin. This formula you should remember, adiabatic process. Temperature, volume, pressure, temperature. Directly remember the formulas. And the units you need to bother, because the units of this cc and here cubic centimeter will cancel out. No need to convert again to the cubic meter. Directly you can bring it in, it will get cancelled out. Okay, we'll go to the next question. Okay, the question belongs to wave optics. The idea involved is YDSC with intensity of slits different. Usually intensity of slits will be same. Here intensity of slits are different. Then the formula for the difference of maximum and minimum intensity. I max. The difference is asking delta I equal to I max minus I minimum. What is I max? Root of intensity of this will be 9I plus root 4I whole square. Root 9I minus root 4I whole square. This will be 3I plus 2I whole square. This will be 3I minus 2I whole square. 25I minus I will be 24I. This will be the difference in intensity at the maximum and minimum point. You need not to bother, sir, like a fringe width, I don't know how many fringes. Need not. Exam is all about question answer. It's all about marks, rank, not knowledge. Fine. When you are learning, okay, think, analyze. But in exam, it's all about question answer. Nothing. What is needed only you have to think here. There's a question based on the gravitation and is asking about the units and dimensions. In gravitation, we'll come across many quantities, the dimensions. So first I'll start with the acceleration due to gravity. Acceleration due to gravity is nothing but the acceleration only. What is the dimensions for acceleration? The dimensions for acceleration will be m0, l1, t minus 2. So here for d it will be 1. Okay, d it is 1. I'll write it here. Then again, we'll take care of the gravitational potential energy, because we know energy will have same thing. So for gravitational potential energy, what will be the dimensions? m1 l square t minus 2. m1 l square t minus 2. I think gravitational potential is here. B will be 3 and D will be 1. B will be 3, D will be 1. You need not to bother about B is 3 here and D is 1. What about sir A and C? You need not to cross check. Directly you have to save time and you have to jump. Okay sir, but you are not verifying. In exam what is needed? You got the option, no? Okay sir, like if the correction is there, then particular add marks will be there. You need not to think on this one. That with the help of B and D, what you have to make a guess and you have to come out. Not guess, because there for B what happened, we have, you can look at here 4, 4, 2, not possible. D, okay, all are 1. I think the question asked so that you should not verify these two. Only take help of this and conclude. It's all about the thinking you have to do in exam, how to save time. Well, this question belongs to the kinematics, based on the kinematics graphs. Which of the following curve possibly represents one-dimensional motion of a particle? There's a position versus time graph. Now definitely you take the slope, the direction of motion will not change. So there's a one-dimensional motion. Then there's a velocity or displacement graph. This will be like a oscillatory, similar to SHM. There's an oscillatory. There's a uniform velocity. All these are one-dimensional motion. There's also distance by time, position versus distance versus time. There's also 1D motion. VT graph, you can see the direction of velocity. With the time, the velocity vector keeps on changes. So this will not represent one-dimensional motion. So which all will represent A, B, and D. Okay, sir, why option C you are not picking up? At various instants, at t equals 0, it's having velocity. At instant of time, its speed will change, and also the direction is going to change. So therefore, this will not represent the one-dimensional motion. Okay, we have the name of chapter, waves and sound, and it's an organ pipe. The resonant tube experiment, there's a tuning fork. The tube is initially fully filled with water, I'll drain out this one. I'll decrease the level of water. So here we'll be having a tap. Using this tap, I can decrease the level of water. Then there's a air column. The first resonance will occur at length 100 centimeter. Next resonance will occur at length L2. Then first resonance will be this will be opponent, this will be antinode, this will be node. This will be again antinode, node, node, this antinode. So half loop, 1.5 loop. So what is L2? L2 will be 3 lambda by 4. L1 is lambda by 4. So L2 minus L1 equal to 3 lambda by 4 minus lambda by 4. Lambda by 2. L2 value we know 140, this 100. This will become 40 centimeter. Lambda will be V by 2F. It's asking to get the speed of sound. Frequency of the sound is how much? 400 Hz. So speed of sound will be 1632 centimeter per second, or this will become 320 meter per second. Convert 100 centimeter become meter. Your answer will be 320. Directly, if you should know this particular formula in exam. You can't draw the diagram, everything. Directly you should manage. L2 minus L1 equal to V by 2F. There's a formula. You should be ready with this formula. Consecutive successive resonances, these are. Chapter name is Semiconductor Physics. We have the logic circuit and truth table. There is a truth table when it is given like this: 0, 0. When both inputs are low, output will be low. When both inputs are high, output will be high. I think this truth table is directly related to AND gate. Where to check it? Is there any AND gate is there? Here it will be A complement, B complement. Here we have the negation. So there is the OR gate. A complement, B complement, whole complement. Then what is Y is equal to? Y is equal to A complement plus B complement, whole complement. So then this will become A complement, A double complement dot B double complement will be A dot B or just AB, which is nothing but the AND gate. I think this will satisfy. You check all the things. Here this will be A, B. Here A plus B. Here some. Here no, there's no connection. Then this will become B complement, this OR gate. So what is Y is equal to A plus B complement. For this I'm discussing A plus B complement. B0, B plus B complement will be 1. A plus 1 will be 1. I think it will not represent this one. Then what about here, sir, this design gate? A complement, B complement. Y equal to A complement dot B complement. There's a NOR gate, so will not satisfy this. Similarly here, A, okay, come for this one. A, B, design gate will be AB. This will be B complement. Then this is Y is equal to AB dot B complement. Will be 0. Only this will satisfy. Okay, now I think really some little bit you have to think of. You can't directly choose it. You have to think it. There's a using mathematical equations, logical circuits. You have to analyze here. We'll choose the next question. Okay, kids, this is the last question I'm having. Chapter name is sufficiency, and the idea involved is excess pressure in the soap bubble. Excess pressure in bubble A is of that bubble B. Find the ratio of volume of bubble A to bubble B. So we'll calculate the pressure. Outside pressure is P naught. The excess pressure is telling. So delta P A, this should be equal to 4 times of surface tension by RA. The excess pressure in bubble B will be 4 times of the surface tension by RB. Of bubble A is half of it. So what is the condition given? Delta P is half of this one. So this will become 40 by RA, 40 by 2RB. RA equal to 2RB. Find the ratio of volumes of the bubble. Volume of bubble A to volume of bubble B will be RA by RB whole cube. 4 by 3 pi R cube. RA by RB will be how much? Will be 2 cube. Will be 8. Eight is to 1. Okay, kids, we have discussed the paper, the 3rd April, the shift 1. You can see that paper little bit more calculations involved. That's all. Rest of everything okay. All formulas and calculations. Because of that, we are calling moderate. If less calculations there, it would have been easier. And what all the moderate questions? What I am putting here. These are the moderate questions. These moderate questions are because of lengthy calculation. Otherwise, the concept involved is easy. Concept involved is easy because of calculations. We are calling them moderate. And there are some 4 questions are there which are a little bit tough, where you should think, analyze. So altogether, okay, it's like a one who has read, remember formula is able to do this paper very easily. Scoring even 90, 94, 96 marks also very easy. So it all depends on the preparation. So the coming, what you have the 4th April, 7th and 8th April. That the methodology is read, remember formulas. Okay, agree this. There's the only thing which will help you in the exams. Huh? Revise or read how much all possible. Recollect, recollect. Hmm? Okay, fine. We'll end up this paper discussion. Once again, everyone, thank you very much for great support. We'll end up tomorrow. This 3rd April, the second shift is there. Shortly, I'll upload it. Thank you once again. Thank you, everyone. I'll end up the session. Good evening, kids. I'm your Sridhar sir, physics faculty. Today we are going to discuss the 3rd April shift 2 evening JEE Mains 2025. The question paper is moderate, and it's better said like a moderate and the formula based. Number of easy questions are around 13, moderate questions are 9, and the tough questions are around 3. And the question paper is purely formula based, almost like all the topics they have covered it. Very good score needed. A very good scoring chapter also, like good paper. The time around 55 minutes you can finish off the paper. Really, and less calculations also, not like heavy calculation. So moderate and simple formula based with the least calculations. There's a overall the paper strategy. Then how to prepare to those who are writing the 4th April or the 7th and 8th sessions, and the 6 shifts are there. You have to read all the theory once again. How much all possible, recollect all the concepts. Then go for the formulas, recollection of formulas. JEE Mains is all about reading and recollecting formulas. The last moment, no need to do PYQ. How much all possible, recollect all the ideas. Okay, fine. So we'll start the paper discussion. So let me explain all the questions in detail and what is the method, how we should think, what is the formula involved, everything. Let me explain. So let me start it. Okay, this question based on the chapter wave optics. The idea of the interference is interference of light produced by the two coherent sources. The ratio of intensity of two coherent sources is 1:9. The ratio of the maximum to minimum intensities. I think we know the formula for this. I max, maximum intensity, is given by root I1 plus root I2 whole square. This will be how much? Root 1 plus root 9 whole square. This will be 16. I minimum will be root I1 minus root I2 whole square. My negative sign will be there. So this will be root 1, root 9 whole square. 1 minus 3 will be 2, 2 square will be 4. This is the I minimum. Is asking the ratio I max to I minimum. 16 by 4 by 4. Somehow you should know this formula. And you should know the basic idea of what you mean by interference, constructive interference, destructive interference. For constructive interference, the phase angle, there's a path difference. The path difference is equal to n lambda constructive interference. Path difference equal to 2n minus 1 lambda by 2 destructive interference. All these formulas. And the resultant intensity depends on I1 plus I2 plus 2 root I1 I2 cos phi, where the phase difference between the waves depends upon the path difference. If the path difference n lambda or 2n minus 1 lambda by 2, this will be constructive interference, this will be destructive interference. Like this, all the formulas you must know. Then okay, along with this also formula. Like this, the basic background if you have, you can manage exam very easily. Yeah, fine. Reading everything, remembering. Sir, but I'm reading, I'll forget. Read again. There's only the strategy left over with the JEE Main, sir. We'll take the next question. We have the next question based on the topic, based on the chapter, alternating current. Here, the idea involved is AC signal with pure resistance only. This particular based on this topic. So let me read the question. An electric bulb rated as 100 watt 220 volt is connected to an AC source of RMS voltage 220 volt. The peak value of current through the bulb. He has given this wattage and the voltage rating. Then from this we can calculate the power dissipated equal to Vrms square into R. We'll calculate the resistance. So power dissipated is how much? 100. 220 whole square by R. The value of R will be by 100. This will become 440 ohm. Now the same, this particular resistance now, where it is connected? It is connected across the RMS AC voltage. So there's a AC source. What is the RMS value of this? 220 volt. The resistance of this is 440 ohm. It's asking the peak current through the bulb. What is the expression for IRMS? IRMS should be equal to Vrms by R. Vrms is how much? 220 volt. 220 by 440. So this will become equal to how much? 1 by 2 ampere. The peak value of current is being asked. Okay, here calculation mistake. 2. Okay, 0. So 22 into 22. I think some calculations I need here. Let me rewrite again. 22 into 22. It will be this will be 484 ohm. This 484 ohm, I'll connect it here. Then this will become 484. This will be Vrms value. RMS value is 220 volt. Now the peak value is needed. Peak value will be IRMS into root 2, because IRMS equal to IM by root 2. IM will be IRMS into root 2. So 220 by 484 into root 2. Okay, 484. So okay, this will be calculations. We can simplify it. 220 is there. 484 is what? 22 into 22. 122 will get cancelled. 10 root 2 by 22. This will become 5 root 2 by 11 ampere. This you need not to expand 484. Keep as it is 22 into 22 and manage the calculations. And we'll move to the next question. Okay, kids, this question is belongs to the chapter kinetic theory of gases. And the idea involved is ideal gas equation. Let me read the question. Pressure of ideal gas contained in closed vessel is increased by 0.4%. When heated by 1 degree Celsius, its initial temperature must be. The concept based on PV equal to nRT. Closed vessel. What do you mean by closed vessel? Volume remains constant. This will be constant. Then delta P by V equal to nR delta T. Dividing these two, delta P by P is equal to delta T by T. Increase it by what percent? 0.4%. The pressure is increased. So 0.4 by 100. When temperature is increased by 1 degree or 1 degrees or 1 Kelvin, what is the initial temperature? This is the initial temperature. So T will be 1000 by 4, 250 Kelvin. Somehow this meaning of closed vessel means volume constant. This is, you have to say, I think you should be very good in English, no? That's why those who are preparing for JEE Main, those who are writing the English exam, better you get habituated for English teaching. It'll be easy for you in exam. If you learn in Hindi, okay, fine, good. But how you deal with the language? If you are Hindi medium, okay, fine, good. But if you are writing the exam in English, preferable English teaching, so that you'll get habituated with the words. This will be a big loss for students who get adapted to the Hindi teaching. Okay, fine. We'll move to the next question. Okay, so this question based on the work energy power. And the idea involved is conservation of mechanical energy. Let me read the question. Two cylindrical vessels of equal cross-section area. They're given this cross-section area 2 meters square, contain water onto up to height 10 meter and 6 meter respectively. The vessels are connected at the bottom by then the work done by the force of gravity. Then here mass of the liquid will be m1, m2. The initial energy will be m1 g h by 2. H by 2 will be 10 by 2. There's the initial, because where the center of mass of this left 2 will be at a height h by 2 plus m2g height, the level of liquid is 6 meters, center of mass will be exactly at the 3 meter. So this will be 6 by 2. What is m1? M1 will be rho, area of cross section, A, volume will be 10. This will be the A into 10 will become volume. G 10 by 2. This will be M2 will be rho A 6. G 6 by 2. So the initial energy will be rho AG you take outside. 10 square 100 by 2 will be 50. 36 by 12 will be 18. So this will become 68 rho AG. This is the initial potential energy. Finally, the liquid will attain the level H. The volume should be conserved, no? The mass should be conserved. What was earlier mass? The same mass it should be. What was the initial volume? Conservation of volume, if you apply. Rho, okay, only conservation of volume. Based on that, A into 10 plus A into 6 should be equal to AH plus AH. So this will be 16 equal to 2H, H equal to 8 meter. The level of liquid in both the vessels will be up to 8. Then final potential energy of the system will be, here the mass will be rho A G H by 2. Okay, it is like this. Huh? Rho A H is the mass of the liquid in the left vessel. G H by 2. Similarly, here the mass of liquid here will be rho A H G H by 2. This will become rho A G H square. Rho A G as it is. H square will be 8 square. Will be 64 rho A G. Then the work done by gravity, the decrease in gravitational potential G. Work done by gravity should be equal to Ui minus Uf. The difference of this will be 4 rho Ag. Substitute the value. 4 and density of water 1000, area of cross section 2 into 10 will be 80,000 joule. Now there's a basic concept. So why h by 2? Center of mass will be here, exactly at half of the level. Okay, then we'll move to the next question. This question based on the chapter semiconductor physics, the idea involved is logic gates. The truth table corresponding to the circuit given below is, here the truth table will be, this is the input A, so this will also be A, the input B, and this OR gate, the output of the first OR gate will be A plus B. Now this will become A plus B input, and there is an AND gate. The output C will be equal to A dot A plus B. Okay, this will be expansion A dot A plus A dot B. A dot A will be A only, yeah? Because A equals 0, output will be 0, A equal to 1, this will be A. Then this will be AB. Take A outside, 1 plus B. Whether B is 0 or 1, the output will be 1 only here. 1 plus B will be 1 only. Okay, this will be your option. This is about the logic gates. Those who are preparing for the 4th, 7th and 8th shift, the logic gates, they are asking numericals more. Earlier they used to ask more about the theoretical one. Now they're asking more numericals. Little bit be alert. You have to work out numerical based questions. And this question belongs to the chapter surface tension, and the idea involved is excess pressure in soap bubble. This formula is what you should know. Okay, let me begin. There's a bubble A, there's a bubble B. Excess pressure inside bubble A is half that of the bubble. Excess pressure is asking. So delta P A should be equal to 4T by RA. Then excess pressure in the bubble B will be 4T by RB. What is the condition given? Excess pressure in bubble A is half of this one. So this will become 4T by RA 1 by 2. Two times of RB. Find the ratio of volume of the bubble. VA by VB. 4 by RA cube equal to 4 by RB cube. So RA by RB will be 2 cube, which is equal to 8. So 8 is to 1. Then this formulas should be there with you. Excess pressure will be 40 by R. For the drop, it will be 2T by R. Okay, fine. A monochromatic light of frequency traveling through air is incident on a medium of refractiveness to wavelength of the refracted light will be. frequency as given, refractance 2 is asking to get the wavelength. So first of all, we know the refractive index. We can calculate the speed of the wave. V equal to C by mu. 3 into 10 to power of 8. Refractive index is 2. Will be 1.5 into 10 to power of 8. After getting this, F equal to V by lambda. Frequency 5 into 10 to power of 14. Speed is 1.5 into 10 to power of 8. This would be the wavelength. Wavelength here it will be we'll substitute here. This will be 3 by 2. 1.5 I'll write 3 by 2. 3 by 2 10 to power of 8 divided by 5 into 10 to power of 14. 3 by 10 or 0.3 into 10 to power of minus 6. 14 minus 8 minus 14 will be 10 to power of minus 6. This can be adjusted as 3 into 10 to power of minus 7 or 300 into 10 to power of minus 9 meter or 300 nanometer. Just basic definition. Speed of light in any medium equal to speed of light in free space to the refractive index. I think this you must know. And for any wave, F equal to V by lambda. Frequency equal to speed of the wave in that medium by wavelength of the light in that medium. This chapter based on experimental physics. Errors. Physical quantity C is given as C equal to P by Q R cube to the root S. Find the percentage change in C. If percentage change in P, Q, R and S are this much, 1, 1, 3 and 2. So what is the formula? This will be dC. Relative error in C is equal to relative error in P, relative error in Q, relative error in R, relative error in S. Okay, all this one. So relative error in P. Relative error in P is how much here? 1. Relative error in Q, 1. Relative error in R, 3. Relative error in S, 2. 1 plus or minus 1 plus or minus 1 plus or minus 9 plus or minus 1. The relative error will be 12. Everyone must having idea of this relative errors. The one which are power into power times the error will get multiplied here. Here select a R cube 3 into dr by r. Here root s 1 by 2 ds by s. And always the error should be added. You should not subtract this one. So like this is denominator minus 3. No, always you have to express maximum possible error. Okay kids, we have the question here based on units and dimensions. Dimensional analysis. The physical quantity is given, we have to match with the dimensions. Let me start with the quotient of viscosity first. The quotient of viscosity. What is the basic formula? Quotient of viscosity. F equal to eta A dV by dx. Force will have unit m1, L1, T minus 2. L square. This will be velocity L T minus 1. This is the L. So quotient of viscosity will be, this L will get cancelled out. This L will cancel out. And here L minus 1, T minus 3. Quotient of viscosity M1, L minus 1, okay, T minus 1. Okay, this will be our condition. Okay, the B is matching with 4. Huh? I think these two are ruled out. You need to give stress. Huh? You can, so these two are ruled out. Now, between these two is what we should check it. We'll take the easy one, thermal conductivity, or you can take the Planck's constant. We'll take the next Planck's constant. Planck's constant means E equal to hf. Energy and dimensions of energy m1, m1 mgh, no, L square t minus 2, or force will be, energy will be force into displacement, so m1 L square t minus 2. Dimensions of h, dimensions of frequency will be t minus 1. So this will become, dimensions of h will be is equal to m1 L square t minus 1. m1 L square t minus 1. So this will be the dimensions of the Planck's constant. So C will be 1. Huh? C is 1. It's available here. And B is 4. You need not to check the other things, sir. This is what you should do in exam. You should save the time. Got the idea? This one. So this will be ruled out. No need to check Boltzmann constant thermal conductivity. Okay, I'll explain it. Thermal conductivity will be like a dq by dt is equal to Ka delta T by L. This is the like a energy. This will be similar to the energy. The energy will be m1. This is the power. Power. This will be m1 L square T minus 3. Thermal conductivity of K, L square, Kelvin K1, and this is L. So thermal conductivity of, dimensions of thermal conductivity will be m1 L1 T minus 3 K minus 1. So this will be, D will be 2. Rest all Boltzmann constant. Boltzmann constant will be K, no? Average translational contingency 3 by 2 kT. Boltzmann constant, how to define that one? It will be average translational kinetic energy will be 3 by 2 kT. Kinetic energy, what is the kinetic energy will be m1 L square T minus 2. Dimensions of K, this will be K. This will be m1 L square T minus 2 K minus 1. Okay then, huh? So these are the ways in which you should work out. Huh? Just practice is needed. Huh? Okay, this question belongs to the chapter friction. And the idea involved is friction on moving block and work done by variable force. Some rough surfaces, some sort of frictional force will be there, and variable friction force will be acting. A block of mass 1 kg moving along x-axis with speed 10 meter per second enters a region ranging from 0.1 meter, rough region ranging from 0.1 meter to 1.9 meter. The retarding force acting on the block is F equal to minus kx, with k equal to, find the final speed of the block as it crosses the rough region. This is the rough region. This region is rough. And how the force? Force is proportional to minus 10x. As the body will undergo retardation. Then initial kinetic energy 10 meter per second. We have to calculate this final speed. So initial kinetic energy F dx mv square by 2. This will be 0.1 to 1.9. Mass of the block 1 by 2. Initial speed 10 square. Force will be equal to 1 by 2 into V square. So this will be 50 minus, okay, this will be plus. Why negative? Why negative sign? It will act opposite to displacement. So therefore this negative sign is there. So minus of 10 x square by 2, 0 0.1, 1.9 v square by 2. 50 minus 5, 1.9 whole square minus 0 0.1 whole square v square by 2. Solving this, final speed of the block is asking. So little bit calculation, there's no other way in exam you should be very good. 1.9 whole square, 3.61, 50 minus, this will be minus 0 0.1 v square by 2. 50 minus 3.61 minus 0 will be 3.6. 50 minus 3.6 into 5 will be 18 v square by 2, or v square equal to 64, v equal to 8 meter per second. Calculations you should be very good. This part you look at. There's a work done by variable force, and that force is retarding force. That's why the speed will decrease. It entered with speed 10 meter per second, here 8 meter per second. Work done by variable force concept. Look, it's this question based on the, here it is waves and sound chapter. Idea of the organ pipes and bits, both are combined. In the resonance experiment, two air columns closed at one edge of 100 centimeter and 120 centimeters. Two organ pipes, length of one is 100 centimeters, the other one is 120 centimeter. Gives 15 beats per second. When they vibrate together, it will give 15 beats per second. And each one is sounding in the respective fundamental. Half loop will be there in each one. The velocity of sound in the air column. You have to calculate the speed of sound in both these. So the 15 bits first F1 will calculate. F1 will be speed of sound by 4L1. F2 will be speed of sound by 4L2. The one which is smaller length will have the more frequency. So F1 minus F2 is equal to how much? 15. This will be V by 4L1, V by 4L2 equal to 15. Further solving, speed of sound we have to calculate. Here 4 will go on that side. L1 will be 100 meter, you convert into meter. This will be 1 meter, 4 into 1. This will be L2 will be 120 centimeter, 1.2 meter equal to 15. V 4 also will take this one, 1.2 minus 1, 1.2 into 60. So 0.2, or this will be 2V by 12 into 60. 6 will be 360 meter per second. Some of the resonant frequencies of closed end or fundamental frequency of the closed end organ pipe. F will be V by 4L. Next, first overtone 3V by 4L. Next will be 5V by 4L. If you know this formula, okay, you can manage this question. Okay. A magnetic, okay, the chapter, the question belongs to chapter moving charges and magnetism. Then magnetic torque on current loop. A magnetic dipole experiences a torque of, when placed in a uniform magnet such a way the dipole moment makes an angle 60 degree with the magnet. The potential of the dipole is asking. Torque equal to mb sine theta. Then torque is how much? 80 root 3. The dipole moment with placed in uniform magnetic field. The dipole moment makes an angle 60 degree. mb sine 60 degree. So 80 root 3 mb root 3 by 2. mb equal to 160. Okay, this is the value of dipole moment into magnetic field. What is the potential G? Potential G formula will be minus m bar dot b bar, which is equal to mb cos 60 degree. What is the value of mb? 160 cos 60 1 by 2 will be 80 joule. Formulas, you must know this formula. You must know this formula. Torque due to dipole moment kept in a magnetic field and its interaction potential G with the field. Okay, kids, done? This question is based on the chapter viscosity. And the idea involved is Stokes' law in terminal velocity. This is the formula. So let me read the question. A spherical ball of radius 1.8 millimeter and density 7825 kg per meter dropped into viscous fluid having density. If it achieves terminal velocity of this much, find the coefficient of viscosity of the liquid. So what is the directly formula for terminal velocity? You should remember this formula, gr square by 9 eta. This will be density of the solid minus density of the liquid. 2 G value will be 10, diameter 1.8 into 10 to the power of minus 3 whole square by 9, eta value. Then the quotient of viscosity, this only we have to find out, will be density of the solid dropped into density 7825, density of the liquid 925. Okay, then terminal velocity will be 245. I think you should be a weak calculation. Huh? You should be careful enough. Huh? We have to calculate the eta. It will come this much. 2 into 10 to the power of minus 4 pascals second. You should manage with these calculations. Okay, fine. I don't have patience to calculate this. Huh? I'll move to the next question. This question belongs to the chapter current density. And we have the grouping of cells. Grouping of cells in series parallel. In the two situations given in figure 1 and 2, current to R is I1, here is current is I1, here I2. If E1 equal 2 volt, E2 equal 1 volt, R1 1 ohm, R2 is 1 ohm. Okay, there's a ohm, huh? The symbol. And R equal to 6 ohm. Okay, fine. So we have this one. Is asking to get this current. Here they are in series. So what is I1? I1 will be equal to E1 plus E2 by R1 plus R2. E1 will be 2 plus 1, 1 plus 2, 1 ampere. What about current here? Grouping of cells. Huh? I'll replace these two cells with an equivalent cell. Okay, fine. This I2. Okay, now grouping of cells. So what is the value of E? E will be E1 by R1, E2 by R2, ordered by 1 by R1 plus 1 by R2. The value will be E1 will be 2 by 1, 1 by 2 by 1 by 1 plus 1 by 2. Five by 3. This will be 5 by 2. This will be 3 by 2. We'll get EMF. This is 5 by 3 volt. The equivalent resistance R is given by 1 by R1. Hope you recollect all the formulas. 1 by 1 plus 1 by 2. 2 by 3 ohm. Then the current I2 will be E by here E1 R is missing. What is the value of R? 6 ohm. I didn't see it. This will be 6. This will be 3 by 9, 1 by 3 ampere. No, What is the expression for? Here E will be E by small r plus capital R. Value of E will be 5 by 3. Small r will be 2 by 3. Capital R is 6. Current I2 will be 5 by 16, 20. This is 18, 18, 20. 5 by 20 will be 1 by 4 ampere. Ratio of this is asking. I1 by I2. I1 will be 1 by 3. This will be 1 by 4. Will be 4 by 3. Grouping of cells, this formula. This formula is very important. And next, this formula. Series, okay, you know this one. It will be net EMF by net resistance. For when the grouping of cells in parallel, these are the equivalent, the internal resistance, equivalent EMF. Okay, this question belongs to the chapter collisions, conservation of linear momentum. The idea involved, a block of mass 10 kg is moving with speed 3 meter per second here, with a spring connected to another block of 5 kg initially attached, and the spring is relaxed. This is a condition. Find the compression spring when both move with the same speed. So when they are moving with a common speed, what is the basic condition is? They will have the common velocity, means at maximum compression, they will have common velocity. Then the compression in the spring will be Kxm, Kxm. Both will be moving with a common velocity. Okay, fine. Both will be moving with a common velocity. Then applying conservation of momentum. Net force is 0. Applying conservation of momentum, 3 into 10 is equal to 10, or so 10 into 3. Initial momentum 10 into 3. Final momentum 10 into V plus 5 into V. V will be 30 by 15 will be 2 meter per second. Okay, this will be the final velocity of the common velocity of the block. At maximum compression, both will have common velocity. This is a concept. At maximum compression, both the blocks will have this idea. You have to remember, useful for advance also. Then we'll apply conservation of mechanics. This is a conservation of linear momentum. Conservation of mechanical. Initial kinetic. This is a test. Spring is relaxed, no elastic potential energy, no kinetic energy. Only this having kinetic energy. So initial kinetic energy plus final kinetic energy plus elastic potential energy stored in the spring. What is the initial kinetic energy? Initial kinetic energy will be mass of the block 10, 3 square by 2. Final kinetic energy 10 V square by 2 plus 5 V square by 2 plus K xm square by 2. This will be 9945. This will be 15 by 15 V square by 2. V value is 2 square. K value 3000 xm square by 2. Okay, finding, we'll get the compression of 0.1 centimeter. Will be in 0.01 meter. Convert into centimeter, we'll get this much of answer. Yeah. Conservation of mechanical energy, initial kinetic energy, final kinetic energy plus elastic potential. Conservation of net force is 0. Okay, done. Okay, this question belongs to the chapter moving charges and magnetism. And the concept involved is A charged particle moves in a magnetic field. It experiences a magnetic force F equal to QVB and is going to move in a circular path of radius R equal to mv by QB. This idea. Now the oxygen hydrogen. So what is the expression for radius of the charged particle mv by QB? Now radius of the oxygen molecule is equal to mass of oxygen with same speed by charge of oxygen O2 minus the magnetic field will be same. What is the mass? Mass of oxygen will be 16 times mass of hydrogen. Same speed. Charge will be 2 times charge of electron. Okay, this will become 8 mv by b. That for the hydrogen will check it. For the hydrogen will be mass of hydrogen, same speed projected, charge of hydrogen b. Mass of hydrogen will be m. Charge of one is like a H plus, no? So charge will be E B. So definitely this is 8, no? So what we are getting, RO greater than RH. Radius of the oxygen molecule, oxygen ion will be that of the hydrogen ion. Are projected, but the radius of the curvature of will be less than hydrogen, but we are getting more, so this is wrong statement. Then similarly, if electron and the proton are projected in magnetic field perpendicular field with the same speed, the radius of curvature of electron, mass of electron, speed, charge of electron b, proton projected, mass of proton v, charge of b. Mass of proton will be greater than mass of electron, Rp greater than Re. The radius of curvature of E will be, electron will be more than the proton. No, in fact it will be less. So this is also wrong statement. Both statement 1 and statement 2 are incorrect. Just the formula, radius of the charged particle in magnetic field, mv by qb. Okay, this question belongs to the capacitors. And the idea involved is charge sharing. Okay, no, we'll begin like this. So there's a capacitor C1, 100 pico is connected to 60 volt cell and then disconnected. So how much of potential difference across capacitor C1 will be 60 volt. Is now connected to an uncharged capacitor. This is uncharged. No charge, initial no charge. The switch is closed. Then the final potential difference will be 20 volt across it. Then charge should be conserved. The charge of these two plates should be conserved. The charge of these two plates should be conserved. Either you can choose this plate or this plate. So what is the charge Q naught? 0. 0. Final charge Q1 plus Q2. Q naught will be C1. C1 will be 100. Pico I'll introduce later on. The calculations you can minimize here. So this will be Q naught will be C1 into 60 equal to Q1 will be C1 into 20. This will be C2 into 20. Charge equal to capacitance into potential. So this will become 6C1, 2C1 plus 2C2. 3C1, okay, this will be 2C1 equal to C2. This 6C1 minus 2 is 4C1, 4C1 equal to 4C2 or 2C1 equals C2. What is the capacitance? This will be 100 picofarad. So C2 will be how much? 200 picofarad. Charge sharing important. Capacitors. Okay, this chapter belongs to waves and so. The idea involved is resonance air column experiment. In a resonance tube experiment at one end, resonance is obtained at two consecutive lengths, L1 100 cm, L2 140. If the frequency of sound is 400 Hz. This is the F. Find the speed of the sound. Actually, this experiment is to find out the speed of the sound. At the first resonance occurs, we'll get the half loop. This will be the antinode, this will be the node. There's a water. The level of water I can control it. This upper surface of the water will become closed and this open end. Then next we'll get like this. One end of loop. Okay, then now what are the resonating length? Will be L1, this L2. In terms of wavelength, lambda by 4, 3 lambda by 4. So what is L1 is equal to? L1 equal to lambda by 4. L2 equal to 3 lambda by 4. Then L2 minus L1 equal to 3 lambda by 4, lambda by 4, lambda by 2. What is lambda? V by F. So speed of sound is 2F L2 minus L1. 2 into the frequency 400. L2 will be 140. This 100. So always we'll get the speed of sound 320 meter per second. All this I explained. Exam directly you should know the formula. The speed of sound in the resonance air column experiment is 2F into successive resonating length L3 minus L2, L2 minus L1 or L4 minus L3. Okay, you have to directly substitute here and so on. You need not to think this much in exam. Got the idea? You should be ready with the formula for the exam. You should know the concept. You should be ready with the formula. Okay, the moment question comes, okay, on this concept, okay, there's a formula, substitute, solve. There's a methodology for JEE Main, sir. Okay, kids, we have the question based on the ray optics and refraction at spherical surface. Chapter name ray optics, refraction spherical surface. Okay, the question, the two media of refractoriness mu equal to 1 and mu dash will write it. Some other symbol will give it. Mu dash equal to 3 by 2 are separated by a spherical surface of radius 50 centimeter. Image of object O is formed at distance 200 centimeter. This is the image. Find the object distance x. What is the formula for this? Refraction at spherical surface formula. Where the refracted ray will come like this. So the incident ray will come like this. Will undergo refraction and this will be the incident ray. Okay, there's a normal something. Then where the refracted is present in mu dash medium, so mu dash into object distance we know plus 200 minus the incident is present in a medium of refractiveness mu, object distance we don't know, minus x, because you have to measure the distance as measured in the direction of incident ray positive, so you're measuring x opposite incident ray, so negative. Mu dash minus mu, this will be plus r plus 50. Mu dash will be 3 by 2. So this will become 200. This will be plus x. 3 by 2 minus 1 will be 1 by 2. So this will everything will be 100. So 3 by 400 plus 1 by x equal to 100. 1 by x equal to 100 minus 3 by 400. One by x equal to, or x equal to 400 centimeter. Okay. If an electron in hydrogen atom jumps from 4th excited state to nth energy state, 2.86 electron or photon is emitted, the value of n. The question belongs to the chapter items. Wavelength of photon in hydrogen spectrum. The de-excitation process. That is the formula when 4th excited state. Just a small basic, like this is the energy level diagram. E5, E4, E3, E2, E1. Fourth excited state to some state we don't know that we have to calculate. So it is making transition from here. This will be fourth excited state. N equal to 5 will be fourth excited state. This is called like a ground state. Okay, no. So what is this will be 2.86 equal to 13.6 electron volt, 2.6 electron, 2.86 electron volt equal to 13.6 electron volt, n square minus pi square, 1 by nf minus 1 by ni square. So this will become 1 by 25. The value of n has to be calculated. So this will become 2.86 by 13.6 or 28.6 by 136 equal to 1 by n square by 25. Solving for n equal to this will be 28.6 by 136. 136. I'm using calculator. 0.21. Then this will be 1 by n square equal to 1 by 25 plus 0.21. Approximately we'll get, it will be 2. You should be good in mathematics. There's a formula for hydrogen spectrum, hope everyone knows, like E equal to the difference energy level. We'll move to the question. Okay, this question belongs to the thermodynamics based on the work done in PV graph. Find out the magnitude of work done in the process ABCD. What is the process? The process is here AB, BC and CD. We have to calculate the work done in the process. So then how much it is work done equal to area under PV graph. This will be change in pressure 3 minus 2 atmosphere, change in volume 2000 minus 1000 liter. So this will be 1000 atmospheric liter. 1 atmosphere liter will be 101. So 1000 into 101.3. We have to express in kilojoule. So 101.3 kilojoule. Area, oh sorry, area we have to calculate. No, area will be 3 minus 2. Work done will be only 3. There's everything will become area. I forgot. Just okay, fine. No work done in the path CD and AB. Only work done in the path BC. Let me explain clearly. Work done in the path AB and CD 0. So net work done is what? Work done in the path AB, CD plus BC. Here this is 0, this is 0. Only work done in the path BC is the work done. Okay, fine. Now this will become 300. And then this will become 304 kilojoule. This is a simple thermodynamics. Area under the PV graph will give the work done. Okay, kids, we had a discussion on the 3rd April, shift 2, the evening shift, JEE Mains 2025. The paper was moderator. Once again, those who are preparing for the 4th April, 7th April, 8th April, the method is read the concepts. Just plain reading, keep on read it. We have so many videos everywhere in the YouTube or here app, webs. Utilize them. Utilize them, that one. Just watch it. Nothing wrong. Not just watching that watching. Any channel where some good explanation is there, watch them. Recollect all the concept. Just keep on listen. Just keep on listen. Nothing wrong. Then next again formulas. Formulas, there's no other choice. You have to memorize. Then solving PYQ. For whom? Those who are dropper, okay, fine. Those who are writing 4th, 7th, 8th, don't solve PYQ because this is not the time. Focus more on these things. The dropper, those who are dropper, go for it. You have a time, no, 8 months, solve PYQ. This is very important. The watching is nothing but the learning here. No, you have to just make observation, okay, how that equation is there, how it is derived, what is the concept involved, like that you have to do it. How you watch movie, like that you watch. Physics movies, chemistry movies, maths movies, nothing wrong, nothing, see like the way of learning has changed. It's not that something you should sit, take book. You can learn through the app, website or the YouTube channels. But you must put effort. See, there's no magic formula. Nobody within 1 hour or 2 months or one day or select this one, nothing is there. You have to just plain reading is needed. What are the total syllabus? You have to watch it. So one shots are there. Watch one shot. Some idea, some help will be there. Then memorize formulas. Memorize formulas, you have to remember. There's no other choice. How to memorize? Daily reading. Fine. So all the best for the kids who are appearing for the 4th, 7th and the April shift. Okay, thank you everyone for great support. So we will meet tomorrow for the 4th April, the shift 1 and the shift 2 papers are uploaded. Till then, take care all of you and the 4th April students, all the best. I'll end up the class. Okay, bye.